All right, so we are working on our next type of factoring, which is your difference of two perfect squares. You'll hear a lot of teachers here refer to this as dots. That's kind of what we shorten it down to. This is our dots factoring. Is when, again, you have two perfect squares. Difference means you're subtracting. So we've got a subtraction here of two perfect squares. So they want us to first write each expression as a monomial squared. So for 49, that would be 7 squared. 7's a monomial, one term, squared. Yes. How about for this next one? What do you think it would be? 4x and then squared. For C? 8y squared, and then D? 10y squared. So because we could write those all as a monomial squared, that means all of these first things here, 49, 16x squared, 64y squared, 100y squared, those are all perfect squares. So that would all work with our dots factoring that we're going to do, our difference of two squares. We're going to write a little note up here. Any even exponent is a perfect square. So you could have x to the 10th. That would be a perfect square because it's an even exponent. However, x to, say, the 15th would not be because that's not an even exponent. So any even exponent is going to be a perfect square. So we're going to classify these down here, whether they're a perfect square or not. So our first one, 9x squared, both parts of it has to be a perfect square in order for it to be classified as a perfect square. So 9's perfect, x squared is perfect because it's got an even exponent. So that is a perfect square. B, though, 4 is a perfect square because it's 2 times 2, but x to the first, that's an odd exponent. This is not a perfect square because both parts have to be a perfect square in order for the whole thing to be a perfect square. So how about C? False. Is 8 a perfect square? No. Yes, but both parts of it have to be a perfect square. 8 is not. How about 25? Yes, 25 would be a perfect square. Doesn't have an exponent. It means it's nothing. Is there a letter there? Then the exponent is nothing. All right, so what I would like you to do right now, A, B, and C, we'll practice our multiplication skills, multiply those out to see what we get as an answer. So go ahead, take a couple minutes, multiply those out. So if you notice, this first one here, we have a difference, because it's subtraction. X squared and 4 are both perfect squares. So this is a difference of two perfect squares. The second one, is that also a difference of two perfect squares? Yeah, we got a subtraction. This is a perfect square because 9's perfect. Even exponent is perfect. 1 is also a perfect square because it's just simply 1 times 1. That's how we get our 1. And then our last one is also a difference of two perfect squares. So this is the setup you're going to be looking for in order to do the kind of factoring we're going to be doing today. So you've got two terms. There is a subtraction sign in between them, and you have to be able to recognize when they're perfect squares versus when they're not perfect squares. So these are what we're going to be starting with, and then we're going to go up here and get the factors. That's what we're going to be working on today. So when you have your difference of two perfect squares, you have, again, just two terms. There's a subtraction sign in the middle, and both of the terms are perfect squares. So once you recognize that you have that, what we do is you do two sets of parentheses. So we set up our two sets of parentheses there. When it's a difference of two perfect squares, your signs are always different. So you have one positive, one negative. It does not matter which one goes first. So then you look at your first term. What multiplies to give us x squared? So x and x. And then what multiplies to give us 16, but it has to be the same number? 4 and 4. And that is exactly what it should look like. Your first terms in your parentheses are the same. Both x's last terms are the same, both 4's. One's plus, one's minus. When you do your big smile, little smile to check, you should end up getting a 0. So my little smile here would be a negative 4x. My big smile would be a positive 4x. Those cancel each other out and we get a 0, which is what we would want to get when we have our dot difference of two perfect squares, our dots factoring. So still, as you're going through this, you want to keep going through that process I was talking about earlier. You want to look for a GCF first. If that's there, you take care of it. Then you look to see if it's trinomial, and then your dots is your third type of factoring. So if we look at letter B, is there a GCF? No. I definitely know it's not trinomial because it doesn't have 3 terms. It's only 2 terms. So is 121 a perfect square? Yep. Is y squared a perfect square? Yep. So we're going to set up for our dots factoring because we have a subtraction of 2 perfect squares. Again, signs do not matter the order. Just you have one positive, one negative. Doesn't matter where they go. So what is the square root of 121? 11. So that's going to be our first terms. The number's first, so the number has to be first when we're factoring. And then what multiplies to give us y squared? Y times y. So then again, our little smile, big smile check. I'd have a positive 11y, a negative 11y. So that gives us a 0. That means we did it correctly. So let's look at letter C. Do we have a GCF? No. Is it a trinomial? No, because I don't have 3 terms there. Is it dots? No. This one looks like it's going to be dots because that is a perfect square, that is a perfect square, but what's my sign in the middle? Plus, what does it have to be? Minus, so this one is prime, this one's not factorable. There's nothing you're going to be able to do with that one. So let's look at letter D. Sorry, I kind of went through our process fast already. There was no GCF, it's not trinomial. We know it's dots. We got 2 perfect squares here that are subtracted. So I set up my 2 sets of parentheses. I put my signs in there. One's positive, one's negative. Again, doesn't matter which one goes first as long as they're both there. So how would we break up the 4x to the 4th? 2x squared and 2x squared. I heard a few people say that. That's awesome. And then the 9? 3 and 3. So again, our check, we would have a negative 6x squared, positive 6x squared, 0. That's how we know we did it correctly. All right, so E, do we have a GCF? No. No GCF. It's not a trinomial, so it's not 3 terms. So that means it's got to be dots. Is this first one a perfect square? Is my fraction a perfect square? It is. So again, one's plus, one's minus. Does not matter where the positive and the negative go as long as they are both there. How do we get our x? X and x. Some people already figured out the fraction, which is awesome. You just take the square root of the top and the bottom separately. The square root of 9 is, square root of 16 is, so our fraction is 3/4 when we do our dots factor. So again, our little check here, little smile would be a 3/4 x. Big smile would be a negative 3/4 x. So those combine to give us a 0. And then our last one on this page, do we have a GCF? Yes. What is it? Y squared. So then that's going to give us a 9x squared y squared minus 49. I take my GCF out. So now if I look at the stuff just inside the parentheses, we're going to kind of pretend like the y squared isn't there, even though it's there. It's like your little sister that you take to the store. She's there, but you don't have to pay attention to her all the time. Is this a dots factoring in there? Yes. So I still set up for dots. My little sister is still hanging out in the front. What multiplies to give us 9? 3. And then the x squared would break up into x and x. And the y squared would break up into y and y. So it would be 3xy and 3xy. How about the 49? 7 and 7. So your final answer is actually all three parts. Your y squared has to be there. And then your 3xy minus 7 times your 3xy plus 7. So then we do have some other special cases that we're going to be going through today. So if we look here at these next ones we're going to factor. Let's look at letter A. Again, we're going to go through our order. If you need to, write your order up here. Look for a GCF. Look for a trinomial. If it's not trinomial, then it's probably going to be dots. So that's always the order. GCF, trinomial, dots. That's why I taught them in that order. So looking at letter A, do we have a GCF?
Yeah. No.
False. No, we don't. But we got 1, 2, 3 terms, so this is going to be our trinomial. So remember, with our trinomial, it's 2 sets of parentheses, just like your dots was 2 sets of parentheses. Our signs, are they going to be same or different? Both going to be. So we get y plus, y plus. So we're going to look for what multiplies to give us 144, adds to 24. 12 times 12. So this, since these are the same inside the parentheses, that gets rewritten as y plus 12 squared. Now, it's not wrong if you leave it as y plus 12 times y plus 12, but I want you to start writing it as the y plus 12 squared because that's going to help us with something in the future that we're going to be doing. So I want you to start practicing that habit now. So let's look at letter B. Do we have a GCF? No. Do we have a trinomial? Yes. So trinomial tells me I set up 2 sets of parentheses. Will our signs be same or different? Same. They're both going to be what? So I got x minus, and we're going to look for what multiplies to be 4 but also adds to be 4. 2 and 2. So how would we rewrite this since these are both the same? X minus 2 squared. Which is, if you remember from my answer key for your homework today, I started doing that. I forgot I hadn't taught you guys that yet. All right, C, GCF. No, but we have 3 terms, so I'm going to start my little trinomial here. Signs are going to be same or different? Same, both going to be. And then what multiplies to 49 but adds to give you 7? That would give me a 14. 7 times 7 is 49, but 7 plus 7 is 14. Prime, that one's not going to work. Because 49, other than 7 times 7, your only other options are 1 times 49, which would not give you a 7 in the middle. There's no way to get that middle term of 7. All right, let's look at D. So do we have a GCF in D? Nope. We got 3 terms though, so trinomial. What will our signs be? Negative. And then what multiplies to 144 adds to 24? 12. Well, no, this one's minus, the other one was plus. So we would rewrite this as y minus 12 squared, because you got 2 of them there. What if I had 3 of them? I would write it as y minus 12 what? Cubed. If I had 3, I would make it cubed. If I had 4 of them, I would make it to the 4th. If I had 10 of them, I'd write it to the 10th. All right, E, do we have a GCF? No. What will our signs be, same or different? Same, good. Now this one's x to the 4th, so it's not going to be x and x. So it's x squared plus, multiplies to 36, adds to give us 12. 6 times 6. So even though you already have the squared on the inside, you're still going to square that whole thing. So it's still x squared plus 6 squared. You got 2 of them there. And then f, trinomial again. Signs are going to be what? Same. Multiplies to 64, adds to 16. 8 and 8. So we got x plus 8 squared. So for all of these trinomials, with the exception of letter C, because that one ended up being prime, you could rewrite them all as y plus something squared or x plus something squared. So these are what we call perfect square trinomials.
Oh, I wrote something different.
So all of your last terms are perfect squares. 144, perfect square. 36, a perfect square. 64, perfect square. 4 up above, that's a perfect square. And then the middle term is when you add whatever their square roots are together. So it makes it a perfect square trinomial. We're going to be doing a lot more stuff with perfect square trinomials in our next unit, so I just wanted to introduce you to them now. What? Not on these ones, no. But you're not going to on perfect square trinomials. It was another special case. You had one special case of dots on the front. This was a second special case called perfect square trinomial.
I was so confused.
All right, so putting it all together. So again, you've got to go through that list in your head of the different types of factoring I taught you. Number 1, do we have a GCF? Yes. What is our GCF? X. You have to be able to recognize this. So I'm going to take the x, put it out in the front, divide each term by x. What do I get in my parentheses? X plus 36. So there's my answer. Number 2, do we have a GCF? No.
What is trinomial?
It has 3 terms, so this is a trinomial. What are our signs going to be? Both negative. Multiplies to 16, but it's going to add to give you a 10. 8 and 2. There we go. And then our third one, do we have a GCF? Do we have a trinomial? Is it dots? No. Plus. Dots needs to be minus. That one's prime. They always throw that in there. That's why I keep trying to give them to you guys. It's got to be a subtraction sign in order to be dots.